Hello student, the question says what is the energy stored in the capacitor between the terminals A and B of the network shown in the figure. Capacitance of each capacitor is given as 1 microfarad. Let us try to solve this problem. So we'll take this diagram. So this is our given diagram. Now, always I will tell you there is a Wheatstone bridge here. Now you might wonder how can we quickly identify that there is a Wheatstone bridge in a given problem. There are two things that you have to notice. Whenever five capacitors are given in a question, if five capacitors, even in resistors also, if five resistors are given or five capacitors are given, that means the other might be hinting you towards a Wheatstone bridge. But don't come to the conclusion straight away. Okay, once we know that here 1, 2, 3, 4, 5 capacitors are there, okay, then you have to think in Wheatstone bridge direction. How do we confirm that he's talking about a Wheatstone bridge only? There must be two inputs and two outputs from a battery. Like example, if you travel from the battery, you can see suddenly we have two inputs. Okay, if you go to the other end of the battery, again suddenly we have two outputs. So we have from one end of the battery two inputs and other end of the battery two outputs. So if these conditions match, if you see number 5 number and these two inputs from one end of the battery and two outputs from the other end of the battery, it means this is also called as junction. So this means that he is clearly guiding you towards a Wheatstone bridge only. This is an easier way to identify whether he is guiding us towards a Wheatstone bridge or not. But let us see whether can we really identify whether there is a Wheatstone bridge here or not. So for that, let me take this diagram. Now just to remove this entire section. So if I remove this entire section from this point, so this was the original section. I will connect the battery a little bit down. So I have removed from this. This is the part I have removed. So this would be plus 10 volt. I have removed this section now. And I took this because this one doesn't have any potential. Here I will connect some ground symbol or anything like that. Actually, I can just take it and connect it here and show you. But this is a fancier way to do it. Now, if you observe it carefully, if I stretch it a little bit, take this diagram and stretch it a little bit, what does it appear like? So on stretching this entire figure would look there will be a slight change in the entire diagram. I will draw in another diagram for that. So this would be my 10 volt. And if I keep on stretching this figure, you will notice that on this side, we will get a capacitor. And on bottom side, we have one more capacitor in between D and C, because this ending is D and this ending is B. We have a capacitor here, and then we have another capacitor here C. We have one more capacitor here, that is C, and finally we are connected to ground. Now we can clearly see a Wheatstone bridge happening here. So we have 10-0 battery, and if this is going, C by C is equals to C by C. That means there will not be any potential difference across this. So indirectly, we can remove the capacitor that is present between D and B. If I remove the capacitor that is present between D and B because of this Wheatstone bridge condition, so let us simply remove the potential difference between D and B. So I'll take my original diagram and then I will remove across D and B. So I hope you understood how we identify that there is a Wheatstone bridge here. Now, this is my original diagram. So once we identify that there is a Wheatstone bridge and remove this. Okay, once we removed it, it is very straightforward question. These two, this is one loop. This bottom part is one loop. So this is one loop. So this marks one loop and bottom part also marks another loop. And since this 10 volt is in parallel with this set, so I can redraw this diagram as we have this 10 volt here. I can redraw that here we have one capacitor. This point is E. We have this point is B. We have one more capacitor and this point is E. And below that I can draw one more capacitor and we have one more capacitor in this way, and this point was my D point, C and C. You can see this is in parallel with this. That means both the capacitors will distribute this 10 volt equally. Since they distribute this 10 volt equally, I can tell confidently that this capacitor would take 5 volt, this capacitor would take 5 volt, because they are equal capacitance. If they are not equal capacitance, then what? If they are not equal capacitance, we have to use, we will use, if Q is the charge flowing through this, Q into Q is equals to C effective into whatever V that is there here. Then we would have found the value of Q. From Q, you would have found what is V1 and what is V2. We no need to do all that here because the capacitance is equal. Once the capacitance is equal, we can tell that they will distribute it equally. Now he is asking us, the actual question was, what is the energy stored between the terminals of this capacitor? Once you know capacitance, once you know this, so energy stored across the capacitor AB is half C into V square. Half C value is 1 microfarad into V square is 25. So we can say 12.5 into 10 power minus 6 joule. So the answer would be 12.5 microjoule. So the answer for this question would be the energy stored in the capacitor between the terminals A and B as shown in the figure would be option A. So this is how you are supposed to solve this problem. The key important thing is that how do you identify that he is talking about a Wheatstone bridge? First thing, to identify whether he is talking about a Wheatstone bridge or not, you should check the number count is very important. Okay, so number count is 1, 2, 3, 4, 5. So if you have 5 number count, that means the other might be hinting towards a Wheatstone bridge. Next, there must be from one end of the battery, there must be 2 entries. Again, from the other end of the battery also, there must be 2 output entries. Understood? So this is another way to identify that the author is hinting you to the Wheatstone. Once these 2 conditions are satisfied, to explain you explained in this much detail, which one should I remove? Whatever these nodes are not touching, the entry nodes and exit nodes, whichever capacitor, the entry nodes and exit nodes are not touching, you remove the other capacitor. See, this is exit node, this is touching here, this is also exit junction, this is touching here. This is entry, this is touching this capacitor, this capacitor. That means I will directly remove this. To explain you, I took so much time and did it. So if I was solving it in a competitive examination, I will immediately identify that this is a Wheatstone bridge. I will remove this. And as I remove this, I will take that this is 5 volt and this is 5 volt and half 1 into 5 square, that is 25. So I would have directly marked it 12.5 without solving so many steps. Now let us see something similar so that you can be familiar with this model. So this is another similar question to the previous question, and how to again identify that there is a Wheatstone bridge here. As I already told you, 1, 2, 3, 4, 5, 5 count. Okay, satisfied. Then if you look at the entry node, we have 1, 2. So we have 2 entrance, and again we have 2 exits also. So we have 2 entrance and we have 2 exit things. Once we have 2 entrance and 2 exit things, now you have to remove the one that is not touching any of them. Once you identify this, that means basically is hinting you towards a Wheatstone bridge. Now you have to remove the resistor that is not touching. This one is touching this point and this point, okay? And this one is touching this capacitor and this capacitor. That means indirectly is telling you to remove this. And remember, this is just a blunt way. I can create a questions that may counter this argument. So this is just a very easier way to identify and solve the problems in competitive examinations like NEET and JEE Mains. We can create circuit that might be counter to my argument, but this will help you really while solving the problems. So hope you understood how I have solved. Thank you.